What? Oh, you can see it? Okay then, so everyone can see me now, right? I hope. Oh, jeez. Okay, guys, so do you want me to work on the question I was on, or should I go back? You guys care? Why is it open YouTube? Okay then, guys, back to the start. Question one. One, if y equals x sine x, then dy dx equals question mark. So A, sine of x plus cosine x. B, sine of x plus x cosine x. C, sine of x minus x cosine x. D, x times sine of x plus cosine x. Or E, x times sine of x minus cosine x. Alright, so this question is asking us to take the derivative of this, right? But we have an x times sine of x here, so we need to use a product rule, right? So the product rule states that we take the derivative of this x, which is 1, times that function, which is sine of x, plus the derivative of sine of x, which is cosine of x, times that one, which is x. So we get sine of x plus x cosine of x as our answer, which is choice B. Okay, question 2. Let f be the function given by f of x equals 300 x minus x cubed. Which of the following intervals is the function f increasing? So interval where f is increasing. Right, so a is negative infinity to negative 10 and 10 to infinity. B, negative 10 to 10, C, 0 to 10 only, D, 0 to 10 rad 3 only, or E, 0 to infinity, right? So this question is asking us to find where f prime is positive, right? Because it wants to know where the function f is increasing. So that's where f prime is positive. So to find where f prime is positive, we need to first find the zeros of this, right? So first we take the derivative. So f prime of x, derivative of 300x would just be 300. Derivative of 3x cubed is 3x squared, right? So now because we want to find the zeros, we need to make this whole thing equal to 0, right? So then we'd add 3x squared equals 300 divided by 3, x squared equals 100. So x equals plus or minus 10, right? So next we'll make a sign chart from negative 10 to 10 because we know that these are our zeros, right, for the slope. Now we just want to find where in these intervals it's positive, right? So let's plug in really big numbers, say 1,000, right, to this equation. We get 1,000 squared, right, which is obviously very much bigger than 300 because it's a minus there. We know that it would be negative, positive, or and then if we have like negative 10,000, right, that squared is going to make it positive, so then you can subtract that again. But if it's between 0 and 10, say like, between negative 10 and 10, say like 0, you get a positive there, right? So you know that it's increasing between negative 10 and 10, right? Which is B. Okay, number 3. Integral of secant x tan of x dx. A, secant of x plus c. B, tan of x plus c. C, secant squared x over 2 plus c. D, tan squared x over 2 plus c. Or E, secant squared x tan squared x over 2 plus c, right? So we want to take the antiderivative of secant x tan of x, right? I'll get to u subs later. There's a question on that, so we'll get there in a bit, all right? We're working on this one now. So now we want to take the integral of this, right? So we can rewrite secant x as 1 over cosine x, right? That's a trig identity. We can rewrite tan of x as sine of x over cosine of x, right? Dx. So that's also equal to the integral of sine of x over cosine squared x dx, right? Which is the same thing as sine of x times cosine to the negative second x dx, right? So now we can take the antiderivative of this, right? So antiderivative cosine of something to the negative second is something to the negative first, right? Times negative 1, right? Well, plus c, right? Because if we took the derivative of cosine to the negative first x, right? Well, so we'll see here that cosine to the negative second x, right? We have two functions, and this sine of x is the derivative of the inside function, right? So then we know that, because this is also equal to something to the negative second, right? So when we take the antiderivative, we have that something to the negative first, which is this cosine of x to the negative first. And because derivative of the inside is sine of x, which is there, we know that we can just leave it like this, because if you take the derivative of this, right, you get negative cosine to the negative second x times the derivative of the inside, which is cosine x. So that's derivative of cosine x is negative sine x. So then your answer would be sine of x times cosine to the negative second x, which we got, which was what was given to us, right? So we know that this here is our answer, because it's cosine to the negative first x, that's the same thing as secant x, or, so the answer is A. Okay, number 4, if f of x equals 7x minus 3 plus ln of x, then f prime of 1 equals question mark. We got A 4, B 5, C 6, D 7, or E 8, right? So first things we'll want to do is find f prime of x. So we'll just take the derivative of this, right? So f prime of x equals derivative of 7x, which is 7, derivative of 3, which is 0, and derivative of ln of x, which is 1 over x, right? So next you want to plug in x equals 1. So then you get f prime of 1 equals 7 plus 1 over 1, which is also equal to 7 plus 1, or equal to 8. So the answer is E. Okay, number 5, right? So for number 5, we're given this graph 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Point 1, comma about 3.5. 2, comma 1. 2, open 2. 3, about 5. 4, a little under 2. Also 4 at 4. 5, about 6. 6, about 4. Right? So this is the graph of f of x. Now it's asking us which of the following statements is false. Alright? So we're given A, the limit as x approaches 2 of f of x exists. B, limit as x approaches 3 of f of x exists. C, limit as x approaches 4 of f of x exists. D, the limit as x approaches 5 of f of x exists. Or E, the function f is continuous at x equals 3, right? So this one wants us to basically look at this graph, right? So now the limit, so now we'll just have to go through all the answers and find which one is false and which ones are true, right? So first we see that the first one is limit as of f of x as x approaches 2 exists, right? So that means that as the graph approaches from the left and from the right, it has to be the same value, which in this case it is. So we know this one is true, so we know it's not false. Then B, it still has to be approaching the same value from the left and the right, right? So 3 is here. It's approaching 5, also approaching 5, so we know that's true. We'll skip C for now. D, limit as x approaches 5 of f of x exists, right? So from the left of 5, it approaches 6, and from the right of 5 approaches 6. So that's true, and which means it's not false. And then the function f is continuous at x equals 3. So continuous just means that it's like has the same value, right? The same y value. So because it's the continuous line there, we know it's not e. And c, the limit of fx as x approaches 4, right? As you approach 4 from the left, you approach the value. You approach this point, which is a little under 2. If you approach 4 from the right, you approach y equals 4. So we know that this one is false because they both approach different values. So the limit of f of x does not exist. Six. A particle moves along the x-axis. The velocity of a particle at time t is equal to 6t minus t squared. What is total distance traveled by the particle from time t equals 0 to t equals 3? So we got A3, B6, C9, D18, or E27. So for this question, we're working on this past multiple choice from 2012 for AB, right? So for this question, they want us to find the total distance. So the total distance is equal to the integral of via t, all right? Because if you integrate via t, which is a rate, you'd get an amount, right? Because the velocity is like, say, meters per second. So if you took the antiderivative of that, you would just get meters, which would be your total distance traveled. So for this one, we want to just take the integral from 0 to 3 of 6t minus t squared dt, right? So the antiderivative of 6t would be 3t squared minus t cubed over 3. The antiderivative of that one from 0 to 3. Now we want to plug in t equals 3 and t equals 0, right? So we get 3 times 3 squared minus 3 cubed over 3 minus 0, right? Because 0 squared times 3 is 0, and 0 cubed over 3 is 0. So now 3 squared is 9, times 3 is 27, minus 3 cubed is 27 over 3 is 9, right? Minus 0. So we get 27 minus 9, which is 18, or answer choice D. Okay, 7 if y equals the quantity of x cubed minus cosine of x to the fifth, then y prime of x equals, y prime equals, so we got a 5 times x cubed minus cosine of x to the fourth, b 5 times 3x squared plus sine of x to the fourth, c 5 times 3x squared plus sine of x, d 5 times 3x squared plus sine of x to the fourth times the quantity of 6x plus cosine x, and then e 5 times x cubed minus cosine of x to the fourth times the quantity of 3x squared plus sine of x, right? So for this one, it just wants us to take the derivative, right? So we have two things here, right? We have an outside function, something to the fifth, and then we have the inside function of x cubed minus cosine of x. So for this one, we'll need to keep in mind the chain rule, right? So first we'll focus on the outside function. So we have y prime equals 5 times something to the fourth, right? And that something is just so happens to be x cubed minus cosine of x, right? But because we have an inside function of x cubed minus cosine x, we also have to take the derivative of that and multiply it by what we get here. So the derivative of x cubed would be 3x squared plus sine of x, right? So then this would be our answer, or answer choice E. Okay, number 8. A tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate RT, where RT is measured in liters per hour and T is measured in hours. Selected values of RT are given in the table above. Using a right-Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals 15 hours? All right, so the table given to us is T in hours, RT in liters per hour, right? So T equals 4, we got 6.5 liters per hour. Time T equals 7, we have 6.2 liters per hour. Time is 12, we got 5.9 liters per hour. And time is 15, we have 5.6 liters per hour. And then we're also given the initial condition that at time T equals 4, there are 50 liters of oil, right? So for this one, they want us to use a right-Riemann sum to approximate the number of liters, right? So number of liters is an amount, right? But they give us a rate. And if you integrate a rate, you get an amount. So we're going to have to find the area of this stuff, which is why they told us to use right-Riemann sums, because those are areas of a rectangle, right? And that will be the antiderivative of the rate, which will give us an amount. So for right-Riemann sums, we're going to want to, the amount would be equal to your initial amount at time t equals 4, which is 50, plus our right triangle, our first triangle, right? It has a base of 3, because you have 7 minus 4, times, because it's the right Riemann sum, we need to use the right y value, which in this case is 6.2, plus the next rectangle is from 12 to 7, right? So that's 5 times the right value, which is 5.9, plus, our next triangle from 12 to 15, which is 3 times 5.6, right? And I'll give you guys the answers right in the middle here. A 64.9, B 68.2, C 114.9, D 116.6, E 118.2, right? So now for this one, we just want to multiply this stuff out, right? So 3 times 16.2, that would be 18.6, plus 5 times 5.9, that's 29.5, plus 3 times 5.6, that is 16.4, 16.8. Right? So now the amount is equal to 50 plus 29.5, so 79.5, plus 18.6 plus 16.8, that's 35.4. Or when you add these two together, you get 114.9, or answer choice C. Okay, that was 8. Number 9. Let f be the function defined above. When we're given this piecewise function, f of x is equal to the quantity of 2x plus 1 times x minus 2 over x minus 2 for x is not equal to 2. Then we're given k for x is equal to 2, right? So let f be the function defined above. For what value of k here is f continuous at x equals 2, right? So to make f of x continuous at x equals 2, that means that this the y value of this one at 2 and the y value of this one at 2 have to be the same thing, right? So, but if we plugged in 2 here, right, we would get 0 over 0, which is a whole, so it's indeterminate. But as it's a whole, we can also look at its twin by taking out the whole. So if we have 2x plus 1 times x minus 2 over x minus 2, we can take out this whole here and look at its twin, which is 2x plus 1. Now if we plugged in 2, right, we would get 4 plus 1, which equals to 5, right? And our answer choices for k were 0, 1, 2, 3, 5, right? So now we know that if we had 2 in here, the y value would be 5. So that means k has to equal 5. So that's answer choice E. Okay, number 10. What is the area of the region in the first quadrant bounded by the graph y equals e to the x over 2 and the line x equals 2? Right? So if we graph that out, right, y equals e to the x over 2, that's an exponential function, so it looks like this, right? Then the line of x equals 2 is there, right? And the area in the first quadrant is all in there, right? So we know that our integral will have, because it's asking for the area, right? So we're going to use an integral from 0 to 2 of e to the x over 2 dx, right? So the antiderivative of that would be 2e to the x over 2 from 0 to 2, because the derivative of e to the something is e times the derivative is e to the something times the derivative of the something, right? So the derivative of e to the x over 2 would be 1 half e to the x over 2. But because we don't have a 1 half here, we have to multiply this by 2, right? So now if we took the derivative here, we would get e to the x over 2. So now we want to plug in 0 and 2, right? So we get 2 times e to 2 over 2 minus e to the 0 over 2, right? So we get 2 times e to the first minus e to the 0. So 2 times e, and then anything to the 0 is 1, right? So we get 2e minus 2, which the answer choices were A, 2e minus 2, B, 2e, C, e over 2 minus 1, D, e minus 1 over 2, and e minus 1. So we know that our answer choice will be A. I'm going to need a new marker. Okay, number 11. Let f be the function defined by f of x equals radical the absolute value of x minus 2 for all x, which of the following statements is true? A, f is continuous but not differentiable at x equals 2, right? B, f is differentiable at x equals 2. C, f is not continuous at x equals 2. D, the limit as x approaches 2 of f of x is not equal to 0. And then E, x equals 2 is a vertical asymptote of the graph of f. Alright, so for this one, it wants us to look at the function, right? So we can rewrite this absolute value into a piecewise function, right? So f of x is also equal to radical x minus 2, then radical 2 minus x, right? When x is greater than or equal to 2, and when x is less than 2, right? Because all an absolute value does is make anything that was negative positive. So when x was less than 2, we would have had a negative here. So we just take the opposite of that, which would make it positive, right? So that's equal to this, right? So let's look at this one, right? The limit as x approaches 2 of f of x is not equal to 0, right? So as x approaches 2, is it anything but 0? Wait, so to check that, we'd plug in 2 for both of these, right? So 2 minus 2 is 0, and 2 minus 2 is 0. So that means that the limit as x approaches 2 of f of x is 0, so we know this one's false. For this one, x equals 2 is a vertical asymptote of f. No, a vertical asymptote is when it's the function is undefined, right? So this isn't undefined here. It's whenever the bottom is equal to 0 of a fraction, but because we don't have a fraction, we know it's not e. Then c after is not continuous at x equals 2. So to check continuity, we look at the original function and we see if at x equals 2, these two give us the same y value, right? So if we plugged in 2 here, we get 0, and if we plugged in 2 there, we get 0. So that means it's continuous, so we know it's not c. Now for both a and b, they want us to check if it's differentiable. So for that, we need to take the derivative of this piecewise. One and a half. Right. So when we take the derivative, we get this here, right? So now we're going to want to check, because they both ask for x equals 2, right? If we plugged in x equals 2 to here, right, we can also rewrite both of these as 1 over 2 radical x minus 2 and negative 1 over 2 radical 2 minus x, right? So if you plug in x equals 2 into here, right, we would get 0 over 0, right? So we get 1 over 0. And same thing here, right? We would get negative 1 over 0 if we plugged in x equals 2, right? So anything over 0 is undefined, right? So we know that it's not differentiable at x equals 2. So we know that it is continuous, but not differentiable. So we know the answer is A. Okay, number 12. Okay, we are given the integral from 1 to 4 of e to the rad x over rad x dx, and we're given u equals radical x, right? So we want, using the substitution u equals rad x, this integral here is equal to which of the following? We got a 2 from 1 to 16 of e to the u du, b 2 from 1 to 4 of e to the u du, c 2 from 1 to 2 of e to the u du, d 1 half 1 to 2 e to the u du, then e 1 to 4 of e to the u du. Right, so for this, we need to replace every x value in here with a u, right? So these 1 and 4, that's in terms of x. This is x, x, this is terms of x, right? So now we need to put everything in terms of u. So if u is equal to rad x, right? So we want to write 1, right? So if x equals 1, that means u equals to rad 1 or u equals 1, right? So our integral will be from 1, right? Then we need to plug in x equals 4 there, right? So u equals rad 4 or u equals 2. So integral from 1 to 2, right? Then this is simpler here, right? U equals to rad x, so we get e to the u over u. Now this dx, right? That's in terms of x. So we can take the derivative of u in terms of x. So if u equals rad x, we can take the derivative with respect to x. So du over dx equals 1 half x to the negative 1 half, right? So now we want to get dx by itself. So this is also equal to 1 over 2 rad x, right? So for that, you can multiply each side by dx and each side by 2 rad x. So we get 2 rad x du equals dx, right? But we know rad x is equal to u, so we get 2u du equals dx, right? So now you can multiply this by 2u du, right? So now we could cancel out this u here and this u here. So our integral would be from 2 of 1 to 2 e to the u du, right? So that would equal c, right? Okay, number 13. So we're given this piecewise function, f of x equals 2 for x is greater than 3, and x minus 1 for x is less than or equal to 3. And then now they want the value of 1 to 5 of f of x dx, right? So they just want the antiderivative of this, but it's a piecewise function, right? So we'll have to do two integrals, one from 1 to 3 and the other one from 3 to 5, right? So this integral of 1 to 5 f of x dx will be equal to the integral from 1 to 3 of this one, right? Because x is less than 3 of 2 plus integral from 3 to 5 of x minus 1 dx, right? So taking the antiderivative of 2x from 1 to 3 plus antiderivative of x squared over 2 minus x from 3 to 5. So if we plug in 3, so we get 2 times 3 minus 2 times 1, right? Plus 5 squared over 2 minus 5 minus 3 squared over 2 minus 3. Oh. And then our answer choices are A, 2 times 3 is 6 minus 2, right? Plus 5 squared. Oh. Plus 5 squared, which is 25 over 2, minus 5. 5 is just 10 over 2, so we get plus 15 over 2 minus 3 squared is 9 over 2, and this is 6 over 2, so that's 3 over 2, right? So that's also equal to 6 minus 2, which is 4, plus 15 minus 2 minus 3 over 2, which is 12 over 2, which is also equal to 4 plus 6, or 10. So the answer is D. Okay, 14. If f of x equals to radical x squared minus 4, and g of x is equal to 3x minus 2, then the derivative of f of g of x at x equals 3 is equal to a question mark, right? So we have a 7 over rad 5, b 14 over rad 5, c 18 over rad 5, d 15 over rad 21, and then e 30 over rad 21, right? So now we're going to want the derivative of this, right? So if we just look at it as f of g of x, right? And we just want to take the derivative of this, right? So isn't this, first we do the derivative of the outside function, so we get f prime of g of x times the derivative of the inside function g prime of x, because we have chain rule here, right? So we have the outside function of f of x and the inside function of g of x. So we took the derivative of f of x, we got f prime of g of x, times the derivative of the inside function, which is g prime of x. And now we want to plug in x equals 3, right? So now we want f prime of g of 3 times g prime of 3, right? So let's plug in g is equal to 3 back into this equation, right? So g of 3 is equal to 3 times 3 minus 2, or 3 times 3, which is 9, minus 2 equals 7, right? So now we have f prime of 7 times g prime of 3. So to find g prime of 3, we first have to take the derivative of g of x. So g prime of x is equal to 3, right? And so g prime of 3 is equal to 3. It's f prime of 7 times 3, right? Now to find f prime of 7, we need to take the derivative of f. So f prime of x is equal to x times x squared minus 4 to the negative 1 half, right? Because this is x squared minus 4 to the 1 half. So you would have 1 half x squared minus 4 to the negative 1 half times the derivative of the inside, which is 2x. So 2x over 1 half, 2x over 2 is x times x squared minus 4 to the negative 1 over 2. And now we want to plug in f prime of 7, right? So we get 7 times 7 squared minus 4 to the negative 1 half, right? So that's 7 over 7 squared. That's 49 minus 4. So that's rad 45, right? So then we get it's equal to 7 times 3 over rad 45, right? So that's equal to 21 over rad 45, right? But we can simplify this radical, right? Because 45 is the same thing as radical 9 times 5, right? And so we can simplify that into 21 over rad 9, which is 3, times rad 5. So if we divide this 3 and that 21, we get 7. So we get 7 over rad 5, or A. Okay, number 15. The graph of a differential function f is shown above. I will draw that out for you. So we have 1, 2, we have negative 1, negative 2, negative 3, negative 4. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts here, ends at about 9, 1, intersects at 6, and it looks like about that. This is the graph of f of x. So if h of x is equal to the integral from 0 to x of f of t dt, right? Which of the following is true? A, h of 6 is less than h prime of 6, which is less than h double prime of 6. B, h of 6 is less than h double prime of 6, which is less than h prime of 6. C, h prime of 6 is less than h of 6, which is less than h double prime of 6. D, h double prime of 6 is less than h of 6. It's less than h prime of 6. Then E, h double prime of 6 is less than h prime of 6. So less than h of 6, right? So we see here, this is all asking about h of x, right? So we want to look at this integral, right? So we know h of x is equal to the integral of f of t, right? So we're going to want to take the derivative of that, right? So h prime of x equals, and the derivative of, when you have the derivative of an integral, right? Because they both, derivative is the derivative, that integral is an antiderivative, that cancels each other out, right? So we'd plug in this f of x, right? But times the derivative of x, which is 1, right? So whenever you take the derivative of an integral, you need to multiply it by the derivative of your what you're plugging in, right? And so if h prime of x equals f of x, h double prime of x equals f prime of x, right? And now we see that it's all asking about 6, right? So let's just put it in terms of 6, right? So h of 6 would equal the area from 0 to 6 of f of t dt, right? And we can see that this whole area from 0 to 6 of the graph of f, this is all under the x-axis, right? So that means that this h of 6 is negative, right? Now h prime of 6, that's equal to f of 6, right? And we see that f of 6 is equal to 0. So we know h prime of 6 equals 0. And h double prime of 6 is equal to f prime of 6, right? Which is the slope. We see here that the slope is going up, right? So that means h double prime of 6 is positive, right? So if we're going from least to greatest, then it's h of 6 is less than h prime of 6, which is less than h double prime of 6, right? So h prime, h double prime, that's a, right? Oh shit, yeah, you guys really can't see the board, can you? I'll try to bring it closer. Okay, tell me if this is better, guys. That gives me a lot less space to walk around. Okay then, number 16. Oh, okay, I'm gonna start using the green marker because this one, it looks like it's dead, basically. 16. A particle moves along the x-axis with its position at time t given by x of t is equal to t minus a times t minus b, where a and b are constants and a does not equal b. Which of the following values of t is a particle at rest, right? So for finding where the particle is at rest, we want to look at velocity and where the velocity equals 0, right? So couldn't we multiply this out? So x of t is equal to t squared minus 2abt plus ab, right? Wait, that's equal to, oh okay, I'll just do this first. So t squared minus at minus bt plus ab, right? So if we took the derivative, right, we want to find v of t, so that's 2t minus a minus b, right, plus a of b. So now if we want to find where this is equal to the particles at rest, that means that the velocity has to equal 0, right? So 0 equals 2t minus a minus b, right? So if we want to find the time, yeah, our answer choices are a, t equals ab, b, t equals a plus b over 2, c, t equals a plus b, d, 2 times the quantity of a plus b, or e, t equals a and t equals b. So now, right, we know that 0 equals 2t minus a minus b. So because we want to get t by itself, we can add a and b to this side, right? Both sides. So a plus b equals 2t, or t is equal to a plus b over 2, which is answer choice B, right? We're just gonna. Okay. I think we'll just have to use the black marker. Okay, number 17. Oh, now the black marker wants to work. 17. The finger above. Yes. Okay. Okay, this is the graph of f. The figure above shows the graph of f. If f of x equals the integral from 2 to x of g of t dt, which of the function can be the graph of y equals g of t, g of x? Alright, so now we want to graph this. So A, it's just a straight horizontal line there. B, C, D, and then E. Alright, so this one is asking us to, oh geez, that is so bad. Okay, so this one is asking us to find the graph of g of x, right? So we know that g of x is equal to the antiderivative of f of x, right? Or if we took the derivative, we get f prime of x equals g of x, right? So that means that g of x, so for g of x, we want to look at the graph of the slope of f prime of x, right? So if this is just f of x, we want to look at the graph of the slope, right? So isn't the slope constantly positive here, right? So the only one here with a slope that's always positive, that's not D, that's not E. Here, this would be also have a concavity, but this doesn't have any concavity, does it? So that means that, and then here, this would be negative, so it has to be A, because it's the only one where we have a positive slope that's constant. Okay, that was 17. This is 18. The limit as h approaches 0 of ln of 4 plus h minus ln of 4 over h is a 0, b 1, fourth, c 1, d e, or e non-existent. So this here is a hidden derivative, right? So for a hidden derivative, you can recognize it because it'll normally come out to 0 over 0, right? Because as h approaches 0, this is ln of 4 minus ln of 4, which is 0, over h, which is 0, so 0 over 0, right? So then a hidden derivative, you can also tell you have a function, ln of something, in this case, and a certain x value, which is 4. So for this one, our f of x is equal to ln of x, right? And we have an x equal to 4. So for a hidden derivative, we just take the derivative of this. So f prime of x equals 1 over x, and then we plug in our x value. So f prime of 4 equals 1 over 4, or b. 19. The function f is defined by f of x equals to x over x plus 2. What points x, comma y on the graph of f have the property that the line tangent to f at x, comma y has slope 1/2, right? So this is just asking us to find the derivative and where that slope is equal to 1/2, right? So for this, we'll just have to take the derivative, right? So f prime of x, but we have a quotient rule here, right? So the derivative, so it's low d high minus high d low over low squared, right? So high x d low 1 minus, wait, low d, no, shit, it's the other way around. So it's low d high, right? X plus 2 times 1 minus high x d low, which is 1, over low squared, right? So this is also equal to x plus 2 minus x over x plus 2 squared, right? So now we want this whole fraction to equal to 1/2, right? So now x minus x, so we get 2 equals 1 over 2 over x plus 2 squared, right? So 2 over x plus 2 squared equals 1/2, right? So if we flip everything around, we get uh, x plus 2 squared over 2 is equal to 2, right? If we just move this to the top, this one to the bottom, this one to the top, and the one to the bottom, right? So then we can get x plus 2 squared equals to 4. 2 times 2 is 4. Take the square root of both sides. X plus 2 equals to rad of 4, which is 2. X equals 0, right? So now if we plug in x equals 0, right, into this equation, right, because they want to find both the points, oh wait, the answers are A, 0, comma 0 only, B, 1/2, comma 1/5 only, C, 0, comma 0, and negative 4, comma 2, D, 0, comma 0, and 4, comma 2/3, and then E, there are no such points, right? So now they want the x and the y coordinate of where the slope is equal to 1/2, right? So we saw that the slope is equal to 1/2 when x equals 0, right? So if we plug x equals 0 back into this equation, right, we get 0 over 0 plus 2, or just 0, right? So then we know that our point where the slope equals to 1/2 is A, 0, comma 0 only, right? Oh, I did so much writing. That's kind of stinky. Okay, then so number 20, right? Let f of x equal to the quantity of 2x plus 1 cubed, and let g of x be the inverse function of f. Given that f is 0, equals 1, what is the value of g prime of 1? Okay, so for this one, we want to find g prime of 1, right? So because g is the inverse function of f, that means the input of f is the output of g, and the output of f is the input of g. So if we want to find where g is 1, right? That means that the input of g is 1, so that means we want to find where the output of f is 1. So that means 1 equals 2x plus 1 cubed. Cube root 1 equals 2x plus 1. Subtract 1, we get 0 divided by 2, we get x equals 0, right? Oh wait, they gave us that right there. Oh, that's silly. Okay. So now we know that we want to find f prime as 0, right? So there's a special thing when there's an inverse function, right? So when the slope of the inverse function is equal to the reciprocal of this one, right? So g prime of 1 would be equal to 1 over f prime of 0, right? So for that one, now we just need to find the derivative. So f prime of x equals 3 times 2x plus 1 squared times 2. So now we want to plug in f prime of 0 equals, it's 2x plus 1, so 3 times 0 plus 1 squared times 2, right? So that is equal to 1 squared, which is 1 times 3 times 2 equals 6. So this has to equal to 1 over 6. Ooh, and the answer choices were A, negative 2 over 27, B, 1 over 54, C, 1 over 27, D, 1 over 6, and E, 6. So we see that's equal to 1 over 6, so we know it's D. Okay, guys, we will be done with the stream now, alright, because it is now basically 3 o'clock and I'm thirsty. And if any of you guys are seniors, UC Santa Barbara comes out right now. So you might want to go check that. And if you have any questions, I guess you can comment them. And maybe I'll see you guys tomorrow. Depends on if you guys join.